So in this lecture, we're going to be speaking about functions. So let's get started. So I'm going to be explaining all the way from the beginning, all the way to trigonometric functions. So a function means that each input has a single output. An input is a domain of the function, while an output is the range of this function. So domain of the function means all of the x values, while the range all of the y values. So if to each value in its range there corresponds exactly one value in its domain, the function is said to be a one-to-one function. So one-to-many relationship is not allowed. So for instance, if you have the same value of x has two different values of y, this relationship is not allowed. While a many-to-one is allowed, it means that if you have different values of x having the same y value, it is allowed. So by definition, there is exactly one y value for each x value. It follows that a vertical line can intersect the graph of the function of x at most once. Now I'm going to be speaking about some characteristics of functions so that when later on I explain and speak about characteristics of functions, you would literally understand those characteristics. So the first type of characteristics is an increasing function. When I say that a function is an increasing function, it means that the function's values are literally increasing, so they're literally getting higher. So the value for it is f of x e to the power of x, which is basically an exponential function. And here a is greater than 0, so it means that this function is literally going higher. It is positive, and it is an increasing function. If we have a decreasing function, it means that the values are going much more decreasing. The value is going lower, the function is decreasing, and an equation here would be a to the power of a negative x. It means that your a value is less than 0. The third type of characteristic is an even function. So if you have an even function, it means that your f of x is equal to f of negative x. So an even function, it means that it's symmetrical along your x-axis. So it means here that it is symmetrical. I mean, along the y-axis, if you see here this parabola, it has 2 points and it's symmetrical along the y-axis. While if you have an odd function, so it's basically negative f of x and f of negative x, so it is symmetrical along the origin, like here. All right, so that's the tan function, and it's basically symmetrical along the origin. That's an odd function. Okay, moving on, I would explain there are several types of functions. These are the most common ones. The first type of function is a linear function, which is y is equal to mx plus b. So m is your slope and b is your y-intercept. That's the equation of a line. Then we have quadratic functions, which is ax squared plus bx plus c. It's basically to the power squared, as you can see. Then you can call it quadratic. There are 3 ways of solving quadratic functions, basically by factorization, completing the square, or by using the formula. I would actually explain these in details later on. The third type of a function is an exponential function, which is ax to the power of a b. Another type of an exponential is e to the power of x. So this one is more common. And your a here, this equation, like in this function ax to the power of b, your a could be any value, so it could be 1, 2, or 3. Sometimes you don't even write the a, so x to the power of b right away. Then we have polynomial functions. They're basically cubic functions, and it means the exponent is cubed, comes from the name. So the function would be equal to ax cubed plus bx squared plus cx plus a d, where a is not equal to a 0. Then we have trigonometric functions. So trigonometric functions are like sine, cosine, and tan. So I'm going to show you how I'm going to talk you through every type of this trigonometric function, like sine, cosine, tangent, the most important ones, and how do they look like, and so on. So these are called sine, cosine, and tan functions. Then we have logarithmic functions. They are basically inverse of the exponential functions. So they have the log, like log a of x for every real x greater than 0. So we have ln with certain values, and these are called logarithmic functions. Then we have reciprocal functions. The graph looks like a hyperbola, like right here. So it means that the equation is y is equal to 1 over x, where x is not equal to a 0. So k is literally, if it's greater than 0, it's a positive function. And if it's k is less than 0, it's a negative function. The function is odd because it is symmetrical at the origin. Then we have the main classification of functions, like you have algebraic, trigonometric, and logarithmic or exponential. Then we have the overview of the elementary functions. We have if you have a zero functions, your f of x is equal to a, so we have a constant function. Then you have f's degree, where f of x a is equal to ax plus b. So that's the linear function, which means that the exponent is equal to a 1. Then we have a second degree, which is ax squared plus bx plus c. So it's a quadratic function. Then we have a third degree, which is ax cubed plus bx squared plus cx is equal to a d, which is a cubic function. So algebraic functions can be expressed as a finite number of sums, differences, multiples, quotients, and radicals involving x to the power of an n. I'm gonna be explaining each type of function, their graphs, how they look like, and so on and so forth. So the first type of a linear function is a slope-intercept form equation, which is m is equal to y2 minus y1 over x2 minus x1. So y is equal to mx plus b, where m is a slope, b is a y-intercept. So the slope is equal to a rise over 1. So if you have two lines, if you have a line, you need to have 2 points for any line, and from there you can find your slope, which is y2 minus y1 over x2 minus x1. I'm going to show you later on how you can solve them. Then if your m is greater than 0, then it's an increasing positive slope, so it means that the line is positive, so it's an increasing line. But if you have your m less than 0, so the function is decreasing, so it's a negative slope. How do I actually remember this? Indicated by the tick mark of a Nike. So the first one, you have this kind of tick mark, so it means that the slope is positive, okay? Then we have, now I showed you 2 examples of a positive slope and a negative slope. Before you actually see it, this line has like the Nike tick, which is like this. So it means that it's a positive slope. So it will have an equation of x plus 1, or basically y is equal to x if it's going through the origin. Both are a positive slope. If you have this kind of a line, you see that it's going in the opposite direction of this line. So it has a negative slope, and it means it's a decreasing line. Then we have other 2 types of lines that we can come across. So the first one looks like that, and your m here is equal to 0. So a lot of students ask me, what is the slope part here? I give it a hack. If you can write the word slope in this line, then it's basically y is equal to right here 1, and your m is equal to a 0. Your gradient is 0. So imagine that it's coming across the point 1, so it means y is equal to 1, and the slope here is 0. If you have this type of line, it's vertical. You cannot write there the word 0 on there. So it means I literally denote it as an undefined slope. So your x is equal to 1 because it's crossing at 1 in this point. All right. Now I'm going to be explaining quadratic functions. So quadratic functions have this equation, which is ax squared plus bx plus c. So your a determines whether you have an open up or an open down parabola. Whenever you have a positive a, you have an open up parabola. Whenever you have a negative a, you have an open down parabola. So this point right here, it's called the vertex. And in order to find the vertex, it's negative b over 2a. So this is the minimum vertex, which is positive a. So if you have an open up parabola, a is greater than 0, which is an open up parabola. If you have a maximum parabola, a is less than 0, which is an open down parabola. So here a is greater than 0, so this is basically opens upward. Or if you have an a less than 0, it means that it opens downwards. So that's the maximum vertex. It's a negative a. All right. Then we have 3 ways for solving the quadratic equations, as I mentioned to you. Factorization, completing the square, and using the formula. The first type is factorization, which means that you need to find 2 numbers that when you multiply them will give you c, and when you add them or subtract them will give you b. When you add them will give you a b, all right? We don't subtract here. So you really need to know how to do factorization because it definitely helps later on. A lot of students I see, they're only doing the formula, which is incorrect. You need to be able to also know how to factorize and also know how to complete the square because it will definitely help you and improve your skills. So a lot of other harder examples for factorization would be when a has a certain coefficient value. So for instance, if your quadratic equation is equal to 2x squared plus 6x plus c, or basically 6x squared, so you have some coefficient. In this way, I usually solve it by using the hack of the triangle. It's basically a very nice hack. When you use it, I will show you how to solve it with it. You generally need to find 2 numbers. When you multiply them will give you a c, and when you add them will give you a b. Then I'm going to be explaining how to complete the square. So to complete the square, you usually have this equation, which is x plus a b over 2, close the bracket, squared, plus c minus b over 2, close the bracket, square. So you simply plug in those numbers, simplify the equation, and then you will have your complete the square. Some scenarios, we can also remove the c in the other side of the equation after the equal, and simply just solve it with using the x and the b. So it will be x plus b over 2 squared and minus b over 2 squared. The third type is using the formula. So the formula is simply x is equal to negative b, positive or minus b squared minus 4ac over 2 of a. Sometimes before using the formula, we usually do the discriminant, because based on the discriminant, we usually would know if we can use the formula or not, because sometimes we do not have roots. So we can simply state there while solving that it has no real roots, and we do not need to even factorize or complete the square or use the formula. All right, so in order to do the discriminant, it's very simple. We use the equation which is right here, b squared minus 4ac. You have your b minus 4ac value. So you will evaluate it. If it's greater than 0, then you would basically have two real roots. Means it would have two solutions. If it's equal to 0, then you would have equal roots. So you would basically have a one solution. Then if you would have it less than 0, so here you have no real roots. So b squared minus 4ac is less than 0. So here it would be no solution. Okay? Then to solve any inequalities, we have two types, linear inequalities and quadratic inequalities. So to solve quadratic inequalities, there are three main things. So to solve the quadratic equation, it's equal to 0, we remove this sign. Then we sketch the graph of this function. Then we solve the inequality using our sketch to find the required set of value. So if your inequality is less than 0, then it's a negative part, so the answer is in between 1 and 2. If your inequality is greater than 0, so it would be the positive part, so the answer would be x less than 1 and x greater than 2. So for instance, you already have your inequality. You would remove your sign, then you would put it equal to 0. You would now factorize it. You already have your 2 points. You would draw your function. Then you would put back your inequality, and if you figure it out that it's less than 0, so it means that it's in the negative part of this function. So you will look at the negative part of this function, so it will be the x is in between those two set of values of your first point and second point. Let's assume it's 1 and 2, so your x would be in between 1 and 2. While, for instance, if you have an equality greater than 0, so it means your x values would be greater than the first point and also greater than the second point. So it will be all of the set of values less than 1, and the second one would be x greater than 2. Okay? Now I'm going to be explaining composite functions and inverse functions. So composite functions, it means that if you have f of g times x, it means f of g of x. This is called the composite of f with g. It is important to realize the composite of f with g may not be equal to the composite of g with f. So you can read the input instead of x, because input is an expression like x plus 1, not only x. So if you have f of x is equal to 2x minus 3, so it's x squared plus 1. So you put there your 2x minus 3 plus 1. So you find your f of g and g of x. Then you also have your f of g of x and f of g of x. So 2x squared plus 1 minus 3. Then if you need to find your g of f of x, it means you need to put your f equation inside of your x value right here. So you put 2x minus 3, all of this is squared, plus 1. Okay? Now we're going to be explaining inverse functions. So we denote the inverse functions as f to the power of negative 1. So it means that your f function of g is inverse to 1 function of f. So for instance, if you have your sine function, the inverse of it would be arc sine. If you have a cosine, the inverse of it would be an arc of cosine. So to find the inverse function, we exchange the role of x and y and express y instead of y. So 2x of plus 1 would be simply x is equal to 2y plus 1. They must be symmetric with respect to this identity. So the inverse of this example, y is equal to x squared minus 4x plus 3, x is equal to y squared minus 4y plus 3. That's the inverse of this value. We also can evaluate the discriminant, so in terms 16 minus 4, 3 minus x. So you would simply find your y1 and your y2 using the equation. Then we have the reciprocal function. It is a hyperbola, which is 1 over x. As you can see, this is a positive 1 over x, and this is a negative. Okay, so if you have your k less than 0, you would simply draw it in these two coordinates. Okay, your domain here is r minus 0, and your range is also r minus 0. Okay, so this is called a hyperbola function, or basically a reciprocal function, which is 1 over x. Okay, so characteristics of functions. We're going to be using these in our functions. So domain is a set of x values, range is a set of y values, decreasing and increasing, I've explained it, which means if a function is increasing, it's basically the values are increasing, getting bigger, and you have the function of a to the power of x, or an exponential function, is also called primarily an increasing function. While a decreasing function, set of values are decreasing, are basically getting more negative, so e to the power of a negative x. Then we have the reciprocal function, which is also called the hyperbola, so it's basically 1 over x. Then we have an odd and even function. An odd function is basically symmetrical along the origin, while an even function is symmetrical along the y-axis. Then we have a maximum and minimum characteristics. Is basically, it is when we explain functions, so the maximum value when you have an open down parabola, it's called the maximum function, and we have a minimum if you have an open down parabola. Then we have the inverse functions. It's basically the opposite of the function. So if you have like sine, it would be an arc sine. So we have, for instance, several ones. So this is an increasing, also in the line increasing, this is constant, and this is decreasing. Also, this type of function, we call this a relative maximum, absolute maximum, relative minimum, and this is no absolute minimum. We're going to be basically using these in very kind of familiar functions like sine, cosine, arcsine, cosecant, arctan, and so on, because they are much more identified there. They're much more clear when you can like characterize those functions. I'm going to be using these in these type of functions. And now we're going to be moving on and speaking about exponential and logarithmic functions. So what is an exponential function? As I mentioned, it's e to the power of x, or a to the power of x, where a is a base and x is the exponent. Okay, so the first type of graph, if you have your a greater than 1, then basically you would have, like for instance, 2 to the power of x, then you would have this type of an exponential function, which is an increasing. So it passes through 0 and 1. The equation is f is equal to 2 to the power of x. So if you substitute x is equal to a 0, your y would be a 1. So in this case, that's your point right here. It means that x increases, your f of x heads to infinity. As your x decreases, f of x heads to 0. That's like the property. Of course, it's an increasing function, as I mentioned. It has a horizontal asymptote along the x-axis, which is right here. So y is equal to a 0. The domain is all real numbers. The range is y is greater than 0, neither odd or even function. This function achieves only positive values. The opposite of it would be a decreasing function if your a is less than 1, or a in between 0 and 1. So for instance, if you have your a is equal to a half, or a to the power of a negative x. So if we again substitute it into this equation, so you would simply know that it would pass through a 0 and 1. So here it's the opposite. As x increases, f of x heads to a 0. As x decreases, which means that it goes this direction, f of x heads to infinity, which means it would go up into infinity. There is a horizontal asymptote along the x-axis as well. Y is equal to 0. The domain is all of the real numbers, which is in the x-axis, x values. The range is a y is greater than a 0, and it is neither odd nor even function. Okay, then I'm going to be speaking about the logarithmic function. As you can see here, it looks the opposite. So logarithmic is the inverse of exponential, since it's going like this. If you draw it, it would be the opposite form. So the equation is log b of x. So your b is greater than 1. So for example, log 10 of x. And the inverse of increasing exponential function is log of 2 of x. That's the inverse of exponential functions. If you have a decreasing function, which is right here, so when a, e, 0, and 1, so your b is in between 0 and 1, so you have your b1 and 1 and 0. So the inverse of decreasing exponential function is your y is equal to log half of x. Then you have the characteristics of logarithmic function. So the characteristics of it is the domain is x greater than 0 and range is all of the real values. It is not even or odd function. X is equal to a 0. It is a vertical asymptote of a logarithmic function. X is the intercept. So if x is the intercept, 1 and 0, and it does not have a maximum or a minimum function. Okay, so the exponential function, as I told you, it is e to the power of x. The natural exponent e value is 2.718. The gradient is identical to the function and it can be used to represent population growth in real life. So now about logs. If you have, for example, how to solve logs. If you have log 10 to the power of 100, so you can simply rewrite it as 10 to the power of y is equal to a 100, which is equal to 2. Again, if you have a log base 10 to the power of 1000, so it means it's 10 to the power of a y is 1000, so your y is 3. It's like a circle. If you have, again, a log 10 to the power of 10, so again, you have 10 to the power of y is equal to 10, so in this case, y is equal to 1. So remember, log a of 1 is 0, because simply if you have imagine if you have here log a of 1, it would be a to the power of 0 is equal to a 1. Okay, and log a of a is equal to a 1. So let a is greater than 1. Let us evaluate these. So if you have log 2 of 1 and you need to find y, so it would be 2 to the power of y is equal to 1. So here your y is equal to 0, because any number to the power of 0 give you 1. If you have another equation, which is y is equal to log 2 of 2, so 2 to the power of y is 2, y is equal to 1. If you have log 2 to the power of 1 over 16, so if you have 2 to the power negative 4 is equal to half, so y is equal to negative 4. Then we have a decadic logarithm. So it's an algorithm with base 10. It's also known as a common algorithm. We write it as a log of x instead of log 10 of x. So decadic logarithm is an algorithm with a base 10. It's also known as a common algorithm. We write it in this way, which is log 10 of x. Now we're going to be saying some characteristics of logarithmic functions. So there are three main characteristics. We have the multiplication law, we have the division law, and then we have the power law. Those are the three main ones. The first one, which is a multiplication law, it's also called the product rule, because simply the multiplication becomes addition. So it is log a of x times y would be simply separated into log a of x plus log a of y. So that's the product rule. Then we have the quotient rule or the division rule. It becomes subtraction. So log a x over y, it's log a of x minus log a of y. Then we have the power rule, which is the exponent. It becomes a multiplier. So log a x to the power of y is simply y log a of x. So we need to prove it as log a of 1 is equal to 0 and prove log a of a is equal to 1. So that's the main laws of the logarithm. You need to know it by heart, or you can simply write it in a piece of paper so that you always have it while solving. Then you need to also know that the change of base of logs. So the change of base logs, it means that when you have another base and you need to change it. So if you have a log of base 5 and you need to change it, or a log of base 10 and you need to change the base of the log. So you would simply write it in this way. So you have log a of x. The x would be the top stays on the top, and the bottom stays on the bottom. That's a hack I remember myself, I remind myself with. So the x would be on top, so you would write the new base, which is b. That's the new base that you want. So it would be log b of x divided by log b of a. The bottom would always be into the bottom. So log a of 1 is equal to a 0. Log a of a is equal to 1. That was from before. The calculators also usually have functions for evaluating decadic and natural logarithms based of 10 and e exponents. If you want to evaluate logarithms, we can use the relationship, which is the change of the base rule log. So log a of x is equal to log 10 of x over log b of a. Okay? So if you want to evaluate logarithms, we can use the relationship, which is the change of the base of the rule log. So log a of x is equal to log 10 to the power of x over log b to the power of a. Okay? Now we're going to move on and speak about trigonometric functions. So let's go ahead and start explaining it. In Greek, the word trigon means triangle and metro means measure. Thus, trigonometry means measurement of triangles, and its use in ancient times was in surveying, navigation, and astronomy to find relationship between the lengths of the sides of triangles and measurement of angles. The hypotenuse is the side opposite the right angle, or defined as the longest side of a right angle triangle, in this case h. While the opposite side, right here, it is the side opposite to the angle we are interested in. So if you are looking at this angle, the opposite would be this side because it's opposite to this angle. The adjacent is a side that is adjacent, that is in contact with the angle we're interested in on the right angle. Hence, its name is the adjacent. All triangles are taken to exist in plane so that the inside angles of each triangle sum to 180 degrees. Therefore, for a right triangle, the two non-right angles are between 0 and 90. The following definitions only define the trigonometric functions for angles in this range. They can be extended to the full set of real arguments by using the unit circle. So we have SOHCAHTOA. So I usually use this rule while solving. You can also know it by heart, and you can say it's SOHCAHTOA. SOHCAHTOA, okay? You can just say a lot and learn it so that you know that your sine value is equal to opposite over hypotenuse. Your cosine is adjacent over hypotenuse, and your tan is opposite over adjacent. So when you say this phrase, you would know that your sine value is opposite over hypotenuse. Your cosine is adjacent over hypotenuse. Your tan is opposite over adjacent. So this is how you can simply remind yourself of the equations. Now we're going to be speaking about the graphs. They can also be shown in Cartesian coordinates. So the first one I would like to discuss is a sine graph. Sine is a period of 360. Functions that repeat themselves are called periodic functions, and sine is definitely a periodic function, which is opposite over hypotenuse. So you start from the 0, you cross the 80, goes down 360. So it means it's a period of 360. So it would repeat every 360 right away. The domain here is all real numbers. The range is from -1 and 1. It means that this point to the minimum and maximum does not cross higher than these two. So this is the range values. It's a primitive function of a 2 pi, which means that it repeats every 360 degrees. We notice that the sign here, it's an odd function because it is symmetrical along the x-axis. So sine of negative x is equal to negative sine of x. The minimum value, if you would like to know it, it is basically 3 pi over 2 plus 2k pi, and the maximum value, it's pi over 2 plus 2k of pi. Then we have the cosine graph. So the cosine here is the domain is all the real values. The range is from -1 to 1, and the primitive, it means it's a repetitive function in the 2 pi. And notice that the cosine of negative x is equal to cosine of x. So cosine is even function, so it is symmetrical along the y-axis. It's a maximum of 2k pi. The minimum of cosine is equal to pi plus 2k of pi. So cosine is a period of 360. It's the same as a sine graph, but translated 90 degrees to the left. And that's how the tan graph looks like. It's basically primitive. It repeats every, it's a period of 180, so it repeats every 180. And it's opposite over adjacent, and the domain values is r minus k plus 1 times pi over 2, where it's for any integer k. The range is all of the real numbers. Right here, it's a primitive function, as I mentioned, of pi or 180. And the equation is sine over cosine, and it does not have a boundary, okay? We also have another 3 remaining trigonometric functions. In modern usage, there are 6 basic trigonometric functions, which are indicated below. These remaining 3 are defined using the above 3 functions. So we have cosine of second. It's a multiplicative inverse of sine function, which is indicated as cosine alpha, which is hypotenuse over the opposite, while the second alpha is a multiplicative inverse of cosine alpha second alpha, which is hypotenuse over adjacent, which is h over b. So your cotangent, it's the multiplicative inverse of tan. So you have your cotangent alpha, it's adjacent over opposite, which is b over a. Then you have your unit circle. So it's from the Pythagorean theorem. It's the equation from the unit circle. The equation from the unit circle is x squared plus y squared is equal to a 1. So that's the equation of the circle. And that's the unit circle. I can also explain to you how you can remember it. You don't have to remember it by heart, but there's a little bit of hack. Like that's a small hack I would show you right now, that when you do, you would actually know right away the values of a unit circle. So to start with, you're going to like mark these, that your x-axis is a cosine and y-axis is a sine. You would have three values, always repetitive: half, square root of 2, 2 over 2, and square root 3 over 2. These two, you would also write them in the y-axis. Half, square root 2 over 2, square root 3 over 2. Those are the three values for the y-axis. For the first coordinate, you would have three main things: pi over 3, pi over 4, pi over 6. Those three. So you would just denote it with a pi. Here is 0, here is 180, which is pi, here is 2 pi, 360. And now you need to know these values. So here it would be 3, 4, 6, always like these in the denominators, they never change. Also here you would do 3, 4, and 6. And also here you would start from this part all the way to the top, 3, 4, and 6. Here the bottom denominators would be, also here it would be 3, 4, 6 for the denominator, starting from this direction, from the y all the way to the top. After you know that these three values would be only pi's, this one would be minus 1 of the denominator. So it would be 5 pi over 6, 3 pi over 4, and 2 pi over 3. While here it would be plus 1 of the denominator. So it means it would be 7 pi over 6, 5 pi over 4, and 4 pi over 3. And here it would be 5, 7, and 11. So this is 5, 7, and 11 values. Alright, so for this circle it would be 0, 1, 0, negative 1, 1, 0, and negative 1 and 0. Okay, then we have special triangles. So for these special triangles, we have two types of triangles. If you can see 45, 45, which is an isosceles triangle, it means like it has those two sides equal to each other. Here to be a square root of 2. And if you have a 360, 90 degrees triangle, it would have like this is a square root of 3, and this is 2a. This is known, like you need to know this by heart. And simply, you can also form this table. You can also use it while solving. And how does this go is that you can simply write in degrees 0, 30, 45, 60, and 90. In radians, it would also be pi over 2, 3, 4, and 6. Your sine values would be the ones that I told you that would be in the coordinates. So half, square root over 2, square root 3 over 2, and a 1. And then your cosine would be the same, but basically like going from downwards, upwards, like opposite to this line. Half, square root over 2, square root 3 over 2. Your tan values, you simply divide your sine by cosine, it will give you your tan. So 0 divided by 1 is 0. Half divided by square root 3 over 2 over 2, it would be square root 3 over 3. This value divided by this value would give you a 1. This value divided by this value would give you square root of 3. Okay, so these are the main ones that I would like to mention. You can always do this table if it helps better than the unit circle while solving. Then, in order to convert radians to degrees, you need to multiply the value by pi times 180. And if you'd like to convert the radians to degrees, then you do the opposite. You multiply it by the degrees, so by 180 over the pi. For angles that are greater than the 2 pi or less than the minus 2 pi, we simply continue to rotate around the circle. In this way, sine and cosine become periodic functions with a period of 2 pi. Sine x is equal to sine x plus 2k of pi, while cosine of x is equal to cosine of x plus 2k of pi. For any angle theta and any integer k, the smallest positive period of a periodic function is called a primitive function, which is a repetitive function. The primitive function of the sine cosine secant or cosecant is a full circle, which is 2 pi or 360 degrees. Now let's speak about the three other functions. So the first one is a cotangent. So it is a multiplicative inverse of tan. So cotangent is a cosine of x over sine of x. Domain is the range minus k of pi for any integer of k, while range is all the real numbers. Primitive function, it is the pi, and it does not have a maximum or a minimum. So that's the cotangent. Then you have a secant. So secant, it's a multiplicative inverse of cosine. So secant, it is 1 over cosine of pi. So it is basically, when you want to draw it, you have to draw the cosine curve, and then you put two boundaries on the cosine curve, and from there you can draw your second between those boundaries. So you know that the cosine here, it would be like going from here to this point and this point. So you would simply draw those parabolas in between the boundaries of the cosine line. And the domain is the real values minus k plus 1 pi over 2. The range is minus negative infinity to negative 1 greater than u and less than 1 and to infinity. It's a primitive function, which means it's a repetitive function along the 2 pi. Then we have the cosecant, so it means that it's 1 over sine of x, which is a multiplicative inverse of pi. So you would simply also draw your sine curve, and from there your cosecant will be drawn in between those two boundaries. So you have to kind of draw the boundary from 0 to 180 is a boundary, 180 to 360 another boundary. From there you can simply draw your parabolas in this direction, and then you will find your cosecant curve. It is a multiplicative inverse of sine, as I mentioned. The domain is a range minus the k pi for any integral of k. The range is from negative infinity minus 1 greater than u and less than 1 to infinity. It's a primitive function of a 2 pi. So now I'm going to be discussing some functions and further trigonometric identities. Those identities are really helpful while solving, and sometimes they are basically presented in tables. They're basically classified in addition formulas, subtraction formulas, double angle formulas, and other rules in books. Addition formulas are following the rule that the sine A plus B will give you this equation, which is sine of A cosine of B plus cosine A times sine of B. Cosine A plus B is cosine A cosine of B minus sine A sine of B. Then you have tangent of A, which is A plus B, is equal to tangent of A plus tangent of B. Tangent of A divided by 1 minus tangent of A times tangent of B. Then you have the subtraction formula, which is sine of A minus B. So it's a sine of A cosine of B minus cosine of A times sine of B. Then you have your cosine of A minus B, which is cosine of A cosine of B plus sine of A times sine of B. Then you have your tangent of A minus B is a tangent of A minus tangent of B divided by 1 plus tangent of A times tangent of B. Then you have your double angle formula, which is sine 2 of A, 2 sine A cosine of A. Then we have cosine of 2A, which is cosine squared of A minus sine squared of A, which is 2 cosine squared of A minus 1. Then you have tangent of 2A is equal to 2 tangent of A divided by 1 minus tangent of squared of A. So these are other rules in the book. Sine x over 2 is square root of 1 minus cosine of x over 2. Cosine x over 2 is square root of 1 plus cosine of x over 2. So then you have other two equations, which sine of x and cosine of x is the square root of 1 minus cosine of 2 of x over 2. The cosine of x will be 1 plus cosine of 2 of x over 2. Then you have the power like formula, which is sine squared of x is equal to 1 minus cosine 2 of x over 2. And your cosine formula, which would be cosine squared of x, 1 plus cosine 2 of x over 2. Now we're going to be doing the inverse of the trigonometric functions. So the inverse of sine functions is arc sine. The inverse of cosine is arc cosine. The inverse of tangent is arc tangent. And the inverse of cotangent is arc cotangent. So if you have the sine, the inverse would be, if you draw the line, it would be like looking like this. So this is the y sine of x, and this is the inverse of it would be sine negative 1 of x. So domain is the arc sine, which is from negative 1 to 1. Range is the pi over 2 and pi over 2. So we can observe that in the interval pi over 2 and pi over 2, ever a horizontal line intersects this portion of the graph. It is no more than 1 point. In this interval, it is 1 to 1 and therefore has an inverse function. Then we have the inverse cosine function, which is arc cosine, cosine to the power of a negative 1. So we have, that's the cosine function. The inverse would be this value, which is cosine negative 1. So how we can draw it? You can simply draw your cosine curve. You will draw the line along the y, like along the origin in the diagonal form. And the cosine would be the inverse, so it would go from the top all the way passing through the pi over 2 and the 1. Because, you know, the distance from here to here is 1, and then it will be vertical, so it would be vice versa. In this case, it will be this vertical distance would be equal to a 1. Okay, it means that the domain here is from negative 1 to 1, as I showed you, and the range is from 0 to pi. Alright, that's the inverse of the tan function, is also an arctane. To also draw this, you have to draw normally the tan function, you draw a line, and that's the inverse of it. It would be in the other direction, in the horizontal direction. Yeah? The inverse of the cotangent is arc cotangent. How you can draw this is also, you need to draw the line, and it would look like this. So it will pass through your half of pi in the y-axis. Okay, the last point I would like to discuss in this lecture is transformations. So you can come across normal functions like a sine of x, and you can have some transformations where you need to do, like for instance, 3 sine of x. So it means that you need to multiply the factor of 3, so it would be sketched vertically. If you have a minus tan of x, it means it's a reflection for the graph vertically. So it will be a reflection because it's positive and it would be in the other direction as a negative. If you have the equation -1 plus sine of x, it means that it's moved 1 unit in the y direction. It's a translation. And if you have a graph which means like half plus cosine of x, it means that the graph moves upward half a unit in the y direction. So it will be half plus cosine of x. Okay, so that's it. Then on the seminar, I will try to solve lots of examples about this topic, and see you in the next lecture.